Hello, and thank you very much for joining us today, and a very warm welcome to you for the forthcoming presentation on how to create sustainable ships by design by Dassault Systèmes Damen. Before we begin, I just want to ask if you have any questions for the speakers to be asked after the presentation, then please write them into the question chat function, and I will endeavour to ask the presenters your questions during the Q&A session at the end of the presentation. So without further ado, let's introduce today's speakers. Firstly, we have François-Xavier DUMEZ, who is the Vice President of the Marine and Offshore Industry at Dassault Systèmes, position he has held since 2021. He is working with the marine and offshore industry for more than 30 years, starting as a research engineer in naval hydrodynamic at the French Ministry of Defense, DGA, becoming next responsible of the numerical hull optimization division. He then moved to the Bureau Veritas Classification Society to be part of the development of the new generation of Veristar products. In 2003, he funded Granite X to develop Silex, an innovative ultra-fast tool for ship modeling and structure mesh generation. In 2010, he joined Dassault Systèmes in South Korea, being responsible of the marine structure specialized applications before becoming the program director of the MATHOT R&D cooperation program, and then responsible of the full CSSC Group 3D Experience Adoption Program in 2015. Our second speaker is Joost, the Director of Products at Damen Workboats Division, who has near 20-year experience in the maritime industry. He has been with the Damen Shipyards Group for most of his career, fulfilling several positions from R&D to project management and from sales to HSEQ. He has a background in naval architecture, obtaining his Masters of Science in Marine Technology from the Technological University of Delft in 2003. Since the 1st of January 2020, he has been appointed as the Director of Products for the Damen Workboats Division. As such, he is responsible for the technology and product development of tugs, high-speed craft, city and fast ferries, and stationary dredgers. The rationale behind the clustering of these products is the opportunity for serial production enabled through a high degree of communality and technical solutions across these products. So before we begin, let me give a brief overview of what will be discussed today. So as I'm sure you're aware, the IMO, the International Maritime Organization, has set ambitious targets to reach net zero greenhouse gas emissions by or around 2050. To drastically slash emissions, the industry will require new and complex technologies as innovative ship concepts and capabilities, greener power and propulsion solutions, optimized hull and superstructure, improved waste heat recovery and energy management. Now, to successfully integrate these different technologies, the industry needs to rethink the entire shipbuilding life cycle, starting by the design phase. So, how to implement low impact design in order to reduce or preferably eliminate the emissions of a vessel in the environment. So, without further ado, I hand over to Dassault Systèmes Damen Shipyards, who will now explore the potential of a collaborative platform to support low-impact design and decarbonisation of the global maritime industry. So, gentlemen, the floor is all yours.
Hello, good afternoon, everybody. So let me introduce first, during a few minutes, Dassault Systèmes. So we are the 3D experience company. So we are a purpose-driven company. We think of progress and innovation in terms of balance and impact. As we create value, what are we taking from our planet? To answer this question, we provide solutions to build virtual twin and virtual world experience with ambition to harmonize product, nature, and life. In fact, we have about 22,000 passionate people from 146 countries across the globe, people sharing the same value and the same passion for innovation. We have also a large R&D team connected across 76 laboratories. One important point is from the beginning, the majority of the company is owned by the Dassault family and the company management. This stability enables a consistent long-term strategy and a long-term investment. Our 70,000 selected partners increase our collective knowledge in the area of technology, sales and services, education, and research. So Dassault Systèmes has the largest PLM market share with more than 300,000 customers. We serve 12 different industries with tailored solutions to address their challenges and business processes. So, of course, marine offshore industry is being one of them. So, by the way, for marine offshore industry, you have developed solutions to address the full life cycle of the ship from the initial concept phases to the ship in operation through basic and detailed engineering, manufacturing preparation, production planning and execution, and commissioning and maintenance. The key value of this solution is the fact that we are able to provide a holistic view of the ship in its environment with the context of usage to capitalize and connect discipline and processes on a common platform, ensuring a global digital continuity with one single source of truth from design to operation. And this provides a huge value in the context of the topic we are going to detail and to discuss today together. So, Joost?
Thank you, François-Xavier. Just a short introduction on Damen. We are a family-owned company based in the Netherlands. And on the next slide, you'll see the mission statement that we have developed. We aspire to become the most sustainable and connected shipbuilder in the world. Now, is a very ambitious mission statement, but I believe that we are well underway of getting there. Just for an overview of what Damen does, we've prepared a small slide on a few overview on the next slide. So Damen is active in many markets, and I would say almost all marine markets, and we have several propositions within those markets. So we do new build, we design and build vessels either on our own yards or in cooperation with local shipbuilders. We offer repair and conversion capability. We have components that we design and sell all over the world. We have a very large services organization with service hubs strategically located in every corner of the world where our installed base is active. And we also service other vessels manufactured by others. And last but certainly not least, we offer financial services so we can offer operational lease or financial lease constructions to our customers. For today, we are focusing on we've chosen this case study, the RSDE 2513, the full electric tug currently operating in the Port of Auckland, as you can see it here. Throughout the presentation, we'll be referring back to this design and how it is, how we did the sustainable design by design. And a short summary would be, every decision that you make, you need to take the sustainability aspect into your considerations, but do that in a integrated and constructive manner, so you can always refer back to it. Now, to move further along, we are going to dive into the approach that Dassault offers on how to be able to do this. François?
So let's move now to the context of this sustainability goals. So from centuries ago to the middle of the 20th century, in fact, the ship have evolved quite slowly on top of few innovation only. So today, in fact, existing ships consume a dirty, heavy fuel oil. And because of that, they are responsible about 13% of the worldwide carbon emission for freight and passenger transportation, with a major contribution to air pollution all over the world. So therefore, International Maritime Organization, as introduced by Jonathan, and Europe have defined sustainability goals to reach a net zero greenhouse gas emission by 2050 for the all delivered new ship. In fact, IMO has defined also intermediate milestone, minus 30% of emission by 2030, for example, versus 2008. Unfortunately, the ongoing trend is not so good. In 2023, carbon emission from international shipping were 20% higher than 10 years earlier. So By consequence, this is a huge challenge, possible only by combining many various new technology together, and some of them being far too immature. So here some examples are shown, like alternative fuels with ammonia, hydrogen, methanol, biofuels, energy management solution, hybrid or full electrical propulsion, wind-assisted propulsion system, vessel performance optimization tools, including routing, control system, and autonomous solution to operate the fleet and the ship. So, but why it is a huge challenge? So, in fact, today, for any of ship design process, there is a direct link between the amount of change or error design and the cost and the complexity of the ship itself. As this is reinforced for the master of any new theory, of course. So fortunately, this trend is smoothed by the capitalization of experience of the naval architect and marine engineers from previous design. So this is what we name the knowledge and the know-how. So, however, because of the needed integration of this new system on board of ships, prior experience is very limited, sometimes empty. So therefore, several design change and error will be involved in the design processes. And it triggers many new needs from design processes perspective, with, in particular, a concurrent access to the 3D design data with high level of collaboration to avoid any silos. Model-based system engineering to ensure consistency between the requirement and the proposed solution. Digital continuity is very important to assess up and downstream impact from any change. Change management, by consequences, change management capacity and traceability, and more accurate simulation and earlier in the design process. So each of these topics has a high value considering the challenge of complexity we have to address. But let us detail some of them, starting with MBSE, Model-Based System Engineering. So in fact, system engineering is known as a must to design complex systems, with a framework of V model like shown here. It starts with the mission analysis, to next move to the requirement engineering, system architecture definition, design of all system and component in 2D and next 3D. To next perform tests on the component, subsystem, and system in the right here in the right side of the V model. But a simple document-based system engineering approach is far from being sufficient in our context. The public studies here show that for high complex systems, most of the error comes from the early phase of design. But they are discovered late during the test of component and system, sometimes on board of the ship for many of them. Unfortunately, this is where the cost is 10, 100, 1,000 times more expensive for error to be solved. So, and this is where the model-based system engineering with multi-physics system simulation allows to reduce drastically the creation of this undetected error early in the design. So, in fact, in context of the design of a ship today, most of the commercial shipyards, the naval shipyard, use already specialized solutions, like the 3D experience or other, to manage requirement and to perform project management, and to cover the processes of design and engineering, starting from initial concept design and next preliminary 3D design, 2D logical diagrams definition, with ability to perform various kinds of 3D simulation, to move next to detail engineering and manufacturing bomb generation, etc., etc. So this is quite usual, and it provides a lot of value already for various kinds of complex ship projects. But for this new generation of very complex sustainable ships, we need more. In fact, without changing the overall process, model-based system engineering as a backbone allows, starting from an holistic description of the mission of the ship, to drive the system architecture definition, ensuring consistency with requirement, thanks to the early system multi-physics simulation. But it's also very valuable to define software architecture and next to test it. So because model-based, it reinforces the capacity of collaboration between the whole discipline in any phase for any kind of modification request or trade-off for alternative design. The changes could be managed easily in terms of up and downstream impact ensuring traceability and consistency. So to explain the value of the system multi-physics simulation, let's have a look on this example. It's a pedagogic one. So imagine a container ship with reefer containers loaded in cargo hold. On board, there is also generator and transformer. Theoretically, generator needs to be used at nominal regime to optimize electrical energy distribution. The purpose of the study is to define a smart electrical switchboard to optimize electrical power distribution, taken into account various ship mission profiles. So let's start the video. So here we can notice on this model 4 cargo holds in the middle. So this is a simplification, of course, for this example. Each of them being packaged with a single dedicated component. So there is also, you will notice both thruster, and you will notice also next additional consumer like the hotel accommodation or the engine rooms. So the purpose of this simulation, it is to size and to check the main component dimension, cable, transformer, generator, by performing load flow simulation to analyze voltage drop and overloaded component with boundaries and controllers. In fact, this model will also allow predicting ship blackout early in the design phases by performing transient simulation for various mission profiles and analyzing inrush current when big consumers are starting, as we can see on some of the picture here. So let us move now on a practical example of application which has been experimented by Damen and many other contributors using 3D Experience as a collaborative platform for design in the context of the European Navies program. Joost, the floor is yours.
Thank you. So a few years back, we already saw this necessity to be able to do all those things that Francois just explained, but we needed to be able to do that collaboratively with several suppliers, with the class society, but we also understood that there was still a lot to be arranged in the application landscape to be able to do it. So that's why we started or joined the Navies project, which we will explain a bit about now. The objective was for Navies project was to have a methodology to be able to develop low impact vessels. Sustainability is not just about emissions or CO2 or NOx, it's about all the emissions, all the damage, if you will, that the product does during its lifetime. And as one of the main solutions to that, we see that we need standard and modular design principles to be able to mitigate those damages or risks. And as a third objective, we see that reinventing the wheel for every ship type over and over again is not effective. We need to have proven technical and economic performance of newly developed vessel concepts based on technology that's already been developed and we can reuse over and over again. And if we go to the next slide, we'll see how the modularization principles were implemented in the whole application landscape. So we started out with the 3D experience, and we are able to do all these things that you see on the screen. So capture the customer requirements, the class approval requirements, all the way down to digital manufacturing and pre-approval issue management. But to be able to do all the things that we need to do, we have developed a landscape where all the suppliers and all the parties that we work with can actually interact with the digital model. So, for instance, to be able to do a proper resistance calculation that we want to do with Marin, a specific integration has been developed. Same goes for the, or a bit different is the CCAT calculation by Bureau Veritas, which we'll touch on a bit later, I think. All of that is now, we're possible to do that from within the 3D experience, and is integrated in a efficient manner. If we move to the next slide, what we now have or are further developing is a module library where from the requirements down to the logical, we have a standard library filled with standard solutions that we can reuse over many ship types. And this is a very beneficial because you don't have to reinvent, as I said, the wheel over and over again. You can reuse the standard solution and only integrate it into your design, but the principles and hopefully most of the parts and the assemblies can remain the same. If we move to the next slide, this has been effectuated on the RSDE, for instance, the vessel that we showed earlier, and we haven't developed one single tug. We've developed a Damen e-drive system, which is modular in its concept and is applicable to many ship types. We are currently applying it to different sizes of tugs, but we've also applied the same concept to ferries. Although it's a very different ship type, the architecture, most of the parts, the control logic, all of that is the same, and in the future will be managed by the Dassault platform. So this is just an example of the Damen e-drive system, but we're expanding that across our entire portfolio. And if you move to the next slide, you'll see a graphical interface where or a representation on how that works. We don't think of our products as single ship types. We look at them as platforms, and you see them on the horizontal axis. So we take a group of vessels that are a product family in essence, and we treat them as one platform, and we ensure that they are modular and can be scaled to the wishes of the customer. And on the vertical axis, you see the system platforms which are defining and driving across those different ship types. Now, if you try to do that for every single ship type individually, that's not sustainable and it's not scalable because you're creating point solutions, and that is something that we cannot keep up in the future. So this is our way of looking at how to create sustainable ships. It's not, and that's the emphasis on ships, multiple, and not a single ship, and that's the way of standardization and driving commonality across those product types with the systems engineering approach as François-Xavier explained earlier. If we move to the next slide, and that also, of course, gives you benefits in the production facility, because if you can have standard modules and even get them up to even perhaps ship sections, then that is going to give you plenty of advantages in the production process, because you can have the same people doing the same thing over and over again and standardizing the work processes. With this modular production method, you can also start simulating the best way to do it and simulate it virtually before you do it, start experimenting on the actual workshop floor, which is of course a lot cheaper, and you can do multiple scenario analysis and define what is the best way to do it for yourself. And sustainability is not just about the ship being sustainable, but also how you produce it. And the amount of work and effort, the amount of waste that you create during the production process is a factor to take into account, as well as safety during production. So this has been done, and we are currently in the process of developing it further. And then we move to the next slide. This is the CCAT calculation method or tool from BV, which has now been completely integrated into the Dassault Systèmes platform, and uses and in that way we can create or do the calculations that are automatically, let's say, verified by BV to be accurate, and do that in a very early initial design stages to make sure that you are complying as soon as possible to the class requirements. And then we move on to the next chapter. I'll address all the life cycle steps within the shipbuilding cycle. What you see on the screen now is what we call our sustainability compass, and it refers to the fact that being a sustainable company or having the mission to be the most sustainable shipbuilder in the world is not just about products. You see those on the bottom axis, sustainable solutions, where we say we want to go have zero emission variants of all our products. We want to have a cradle-to-cradle view on how we do our things, how we do the things, and of course innovating in creating more value or more products that actually have a sustainable purpose in life. But there are other aspects. Sustainable operations on the top right. It's about occupational safety, health and safety during construction, but also health and safety of the crews on board. It's the environmental footprint of your company. How much energy do we consume during the production? How much energy can we generate on our locations, adding solar panels? But also, how do you engage with local communities? These are all aspects that are of the essence when you're trying to be the most sustainable shipbuilder in the world. And on the left, about sustainable organization. Yeah, it's about your employee commitment. It's about legal and compliance and performance monitoring. It's also about doing business ethically. Where do you source your materials? How are your subcontractors being monitored, and how are they doing their jobs? It's all part of that mission statement. And in the end, we will deliver sustainable ships, but how you do it is equally important. Moving on to the next slide. The circular economy or cradle-to-cradle aspect is very important. We get questions on how much emissions do we emit with our products, but also from what type of material are they constructed. And that is also a part of how to create sustainable ships. You need to take that into account, but it's very it's a challenge for us, but it's also a challenge for our suppliers, because we need to have transparency and insight into the whole production chain, not just on our tier 1 suppliers, but our tier 2, tier 3. And that's where we need to get together and ensure we use data we can interchange, we can interact with, and we can follow up on, because how we're doing it now is very, let's say, labor intensive, and if I dare to say it, inaccurate, based on lots of assumptions. And you would really have that, preferably have that in a much more data-driven manner. The next slide is the RSDE, as I said. So this is the culmination of all the effort that we put into working on a Damen e-drive, working on systems engineering, and this is one of the results of what we call a very sustainable ship. And it's not just about the propulsion system, which is fully electrical, but there are also safety features in there. On the top left, you see we have electronic stability protection, which basically says that if the vessel heels too much, the captain will get an alert that he needs to interact, needs to take provisions. It's also a much smaller vessel for the same amount of bollard pool than compared to a conventional vessel. So you have a less, it's a very compact, so you need less steel, less of everything to have the same performance in the water. To be able to do that and to have it controllable and core stable, you have a twin fin skeg design, which ensures that the vessel is controllable in all directions. And I could go on. So the point I'm making here is it's not just about emissions, it's about every single aspect of this vessel. Sustainability, safety, environmental footprint has been taken into consideration all along, because it was written down in the requirements, translated into the functional, down to the logical and the physical, all through that systems engineering V-cycle. And that's the way to get that done. I think we move on to the next slide.
So I think Thank you very much, Joost. As presented with your example in the Damen Sustainability Compass, the environmental impact from cradle to grave is a key aspect of the development of the ship product as of today. In fact, since last July, International Maritime Organization is enforcing the usage of life cycle assessment method for fuels, especially. But it will be soon necessary to consider the life cycle assessment for the whole shipbuilding process, in fact. So shipyard and more generally the whole maritime supply chain will be encouraged to demonstrate what is the environmental impact of their product. It's not only to take commitment, but also it is to be able to share and to demonstrate the footprint. So environmental impact will become very soon a metric to be monitored during the design and engineering processes, like the weight or the cost as presented here. So in fact, as raw material have a high contribution to the CO2 emission because extraction, because the transport, the manufacturing, and the recycling, the reduction of overall dead weight of the ship or the size will contribute to the CO2 emission reduction. But the lower the weight and the lower the environmental impact. So the more the cost will increase. So this is opposite. So therefore, a solution is needed to manage in parallel all these parameters, to make a trade-off between alternative design and to find the best balance between each of them during the design process. It allows also to compare at any moment the targeted value of CO2 emission or other sustainability criteria, as mentioned by Joost, versus the computed one, and later the measured one, thanks to the virtual twin in operation and the feedback, the return of experience. So LCA methodology, life cycle assessment methodology, and LCS solution are here to make sustainability KPI and CO2 emission first at the heart of the design process. So for shipbuilding activities, it means being able to define, to compute, and to monitor the contribution of each of the single part, component, subsystem, and system of the ship for any kind of discipline directly from the 3D model. For example, in 3D Experience Platform, our LCA solution uses EcoInvent database, which provide formulas for thousands of human activities and processes. And it could be enriched from your own knowledge or return of experience. So, Joost?
We have an example. This is the electric ferry that operates in Copenhagen. And it was already in service for a few years now. And we, as an exercise, tried to do the LCA analysis on this with not the tool set that François-Xavier just mentioned. And on the next slide, you'll see the outcome of that. And what it says is that we have a circularity on the ferry of around 50%. Which you might say, well, that's not too bad. But if you look at the numbers below, we have a lost potential of around 33%. So that's the amount of material that we can't recover to have back into the circular economy to reuse in some sense. And that's for all very different reasons. But one of the main things is, we just don't know where the material comes from. So the database that François just mentioned, that's going to help us incredibly in making these numbers more accurate, more reliable, and that is what the customer is asking from us, and we really want to be able to provide. But right now is very hard to get that information all together. So to be able to do a proper LCA analysis, you really need to improve the data management of all those things as just mentioned.
So thank you very much, Joost. So let's also have a look on this short video I will show you now, because to check how the mapping of real data, I was talking just before about return of experience of ship in operation. Real data in the platform, 3D experience platform here, could help to monitor the performance of the system on board, because it will impact also the sustainability goals for sure, if we are able to optimize in continuous matter the performance of your system. So for example, here the ship information system for the energy management optimization will rely on data acquisition on board about the operational status of the ship and the main engines, like temperature, pressure, flow rate, etc., etc. So remote onshore monitoring of this data will allow to detect, to analyze, and to provide feedback to the crew in order to improve the energy efficiency of main system and equipment on board. So let's have a look. So here, data are visualized through a set of widgets to have a clear view about the general status of the vessel at a given time. So specific KPI make it possible to monitor them and issue a visual alert if something happens wrong. So data are visualized. So it is of course possible to visualize the 3D model. You can then navigate from one device to another one which is connected to it to quickly understand the context of use. Next step is to access the document associated with the system. Here the maintenance manual, but it could be a classification, regulation, or whatever. It's possible to capture remarks. You have access to the history of the equipment with a calendar view of its maintenance cycle. You can review. We'll see it very soon. Yes, you can review the in situ measurement made on the component of the system to understand the cause of the malfunction and to define a maintenance plan, creating tasks, as we can see, shared with the concerned actors. So here, in that the solution offers a very intuitive interface to analyze and to converge toward a preventive or corrective action plan in regard of the maintenance or sustainable KPI. So let's conclude this presentation. So what do we see today in the market? So a radical technological transformation. So those transformations impact the whole ecosystem, because sustainability needs to be in the core at every step of the life cycle. So from initial concept phase to the ship in operation, all of the stakeholders, shipyard, design office, supplier, classification society, ship owner, and port have to be involved and to cooperate together to address this challenge about integrating new technology on board of the ship. So, for example, a Green Corridor initiative requires already massive investment from port and operator, covering everything from bunkering facilities with alternative fuels, renewable shore power, ballast water treatment, and inland connectivity. So, platform of collaboration for design and simulation, like the 3D experience, are really critical assets to support and to succeed this transformation, which is very, very challenging. So thank you very much. Joost, if you want to say a word. Cool.
This is a very good graph because it's an endless cycle of cooperation, collaboration between all the stakeholders, and only through all the stakeholders involved can we make that transition. We as a shipbuilder can develop a sustainable ships, but if the customer, if our customer, the operator, is not incentivized or isn't motivated or isn't allowed to bring a sustainable ship into operation because of port requirements or class requirements or what have you, it's an effort from all of the stakeholders, from regulatory to end users, operators, suppliers. All of them need to make a step. Otherwise, we're just looking at each other and waiting for the first one to move. We all need to move, and I think we've just shown that the software developers are ready. We as a shipbuilder are definitely ready, and I invite all other stakeholders to step up and let's make this world a better place.
Thank you very much. So here we are. Jonathan.
Great. Yeah, certainly.
We're going to questions and answers.
Well, I just want to
Hello. We have lost Jonathan for the question and answer session.
Go ahead, Jonathan.
No, I'm right here. Don't worry, gentlemen. Yes, thank you ever so much for the presentation that you've given. It's very interesting to see the work that you're actually doing in such high detail and definition with regard to helping develop sustainability within ship development. And as you touched on there, Joost, at the end, you know, it's organisations such as yourself that are actually putting their toes in the water, or maybe feet in the water, feet in the sea, to we're moving forward and getting it done. So, yeah, so I have a few questions for you, gentlemen. So you said we're moving into the Q&A session. Firstly, to ask you that according to your Navier study, what are the benefits to adopt a modular approach?
Sorry, the question is, what are the benefits?
Hello?
Yes.
Sorry. Yes. What are the benefits to adopting a modular approach from the study that you've done through Navier?
Right. So it's it has multiple benefits, and one of them is that if you have a modular approach, then it is easier to do midlife upgrades throughout the life cycle of the ship. So we know what kind of technology we're integrating or building now, but we don't know what's going to be available in 5 or 10 years. So if you take, for instance, the best example is a battery system. If you ensure you have a modularized approach to your propulsion system and the battery system, that it's an easy plug and play concept where you take out the batteries and you install a new set with the same, well, more or less the same interfaces. Or if you know what is going to change, programmable interfaces, then you make your life easier for the customer, but also for yourself as a shipbuilder. Another benefit is if you can have the same module applied across multiple ship types, you only have to invent it once and maintain it once and reuse it across multiple ship types. So there's many benefits that you can imagine with having a more modular approach.
And in addition, by the way, means that we know that the target from sustainability perspective are still far to be reached. So, and we'll need to have multiple upgrade in the future. So if you have module, you will make a continuous upgrade along the life cycle of the ship by improving the efficiency with new equipment on board, and it will facilitate the upgrade capabilities. So definitely, there is a lot of value.
Yeah. Great. And with regards then to classification, what's the role then of the classification when adopting a modular design approach then?
In principle, you could have. I'm sorry. You're going to ask it to François. Go ahead, François.
No worries.
We can answer both of us. Means that in the context of the Navier studies, means that it was Bureau Veritas, but it was a R&D topic. It is still not fully industrialized, but it was to be able, in the principle, to review the module through an approval in principle, which means that next you will be able to speed up the overall classification because some of the module will have been approved before, at least in the principle, so it should be okay for the final classification of the module and by consequences of the complete ship. So this is the idea, acceleration of the, and within context of this sustainability, of course.
Okay, Great. Joost, did you want to touch on anything with François?
No, I was gonna. We recently received the approval in principle of our new methanol system that we're working on, and it's exactly that. So it's we haven't designed a ship yet. We've designed a methanol system on how we want to apply it on small ships. There is no rules and regulations in place yet. It's the rules and regulations that are there are for large vessels. We have taken a specific design approach, and we've already had it approved in principle by class by taking a modular approach to it.
Okay, excellent. Yeah, well, certainly. Yeah, the work's going forth, isn't it, in that area? The work that you're doing there and getting it classified to certainly get it, I suppose, built and operational then in that front. With regard to the databases you spoke about during your presentation, what database do you use to measure environmental impact? And is it specific to M&O, for example? Sorry, M&O, for example.
I may answer means that in our case, this means that our life cycle assessment module, LCA, is based on the EcoInvent database, which records, in fact, more than 80,000 human activities, for each of which a technical note is published and available as soon as you want to use it in your context of your computation. You will know exactly what is the scope, what is possible, what is attached regulation or constraint. So as of today, to answer the second part of your question, there is no dedicated marine offshore database on the market, but in fact, EcoInvent database cover most of them. And so, 80,000 is quite huge. And it is possible, of course, to build specific and to define specific human activity directly in the application, or import a list of activities from Excel or whatever you have done in the past. So it is open to be tuned and to address your specific challenge or specific computation.
Okay, excellent. Yeah, okay, very good. And it was interesting as well to see obviously the work that you've been doing in creating the electric tugboat Sparky. I wanted to know, do you have any customers already buying this Joost, or is it still out for order as such?
No, we have. We just sold one to the Port of Antwerp just a couple of weeks ago as part of a larger order. They are also ordering 5, let's say regular, but with IMO Tier 3 engines, and 1 fully electric copy of Sparky. And we're very excited because it's for us, it's the second customer. And we see that in the broader market, electrical designs are catching on, and we have some stiff competition, but we're very open and welcome to that because it keeps us all stronger, keeps us all sharp. And there's 4 more or 6 more under construction. So if there's anybody out there that wants to buy one, please feel free to approach us.
They can get in contact directly with the Joost through LinkedIn, can they? With their specifications.
No problem.
Great.
Yeah.
Great. Well, fantastic. Well, you've heard it here. Reach out to Joost if you have any particular requirements in this area. And I'm sure him and Damen will be able to address your needs as such. But we have from the audience, a gentleman by the name of Stanislas Oriet has asked, how do companies like yours collaborate with material providers such as steel, copper, etc., or even push them for cleaner work processes to ensure your own products have lower environmental impact?
Right. As you can imagine, the Damen Group buys a lot of steel. So what we do is we create partnerships, and in those partnerships, we define what we expect from a supplier on different levels, and also on sustainability aspects. And together we come up with a plan on, okay, this is what we expect from you. This is where we both agree that you're at, and these are your development points. And how are you going to move from A to B? And it's part of a, let's say, systematic approach to working with your suppliers. And in some cases, yeah, we have to accept that performance isn't as we wanted in some areas, but we develop programs to make sure that they come up to where we want them to be. And if that doesn't work, yeah, we say goodbye and we move on to a next supplier. But we don't. That's not the end game. But in sense, the answer is already in the question. We work with them together, and together we define a plan. Okay, how are you going to get there? Collaboration again.
Great. So everyone's working together. Mm-hmm.
Yeah.
Reading off the same hymn sheet, so to speak. Great.
Yeah.
Great. And working and moving forward as one. Great. So we have another question from John Barlow. He has asked, is Damen focused only on the short tug or pilot boat? And also, have you looked into swath, small water area twin hull design for long haul? They have greater stability while being fuel efficient. They're faster by design. Similarly, have greater load capacity ratio by size.
Damen is, as you saw, involved in many markets, and we've developed many ship types. We've even built a few swaths in the past. Currently, swaths are no longer on the, let's say, on the design roadmap, which is a careful consideration of what are the requirements that the market is asking, what do we feel is the best technological solution, and how many R&D hours can we spend. But I'm not. I don't think it's wise to have a let's say in-depth consultation on what I think about swaths and other. But because there's many different hull shapes, catamaran, trimaran out there. For now, they are not on the list, but that could change in the future.
Okay, great, thank you. And we have a question from Gideon Ameniki. He's asked, how can we ensure that the design of ships considers the long-term sustainability of our oceans and marine ecosystems?
I think I already answered that question with the modularity approach. You need to take into account that a ship is going to be in operation for the next 20 to 30 years. And how do you enable it to be updated and upgraded to new functionality? That's something that you need to design in from the start. And with a modular approach, you can do that.
Great. Okay. We have from a LinkedIn user, he says, thank you very much for the presentation. And which of these transformations are you betting the most on? So I suppose betting the most on to succeed and do well.
Yeah, I think if I make the assumption that the user or the question is related to our mission statement, sustainability and connected, one doesn't go without the other. That's what our thinking. If you want to make a product more less environmentally or sustainability impactful, if you want to lower its impact, you need to optimize. You need to optimize the way it's operated, the way the systems on board are working together. And you can only do that if you know what's happening on board. So you need to monitor it. That's where the connected part comes from. And you need to make sure that all the components on board are actually, let's say, influenceable. You need to be able to let that all interact. And that's where a higher degree of automation comes from, to make sure that you have the opportunity to dial on different knobs to make sure you have the most efficient operation that you can have. So digitization, being connected, is a enabler for being more sustainable.
Okay, great. And I have another question as well. I think perhaps could be answered by the both of you. It's from Adana Okonkwo. She's asked, do you collaborate with researchers in any way?
From our side, yes. Naveis example is a good one. Means that because we were also part of this R&D project. So and we have many other. Means that some are not finished, so it's difficult to speak about it now. But definitely mean that we invest a lot from the system perspective in R&D. On any topic, not only for mine offshore, but and some topics like electrification for transport and mobilities, or eVTOLs, this kind of technology for the future hydrogens propulsion as well. In that we are part of many R&D projects to define new technologies and to support this sustainability goal for the future. Yes, for sure.
Yeah. And for Damen,
and yourself, Joost, the Damen?
Yeah, it's the same. We work with many academia from different topics, different knowledge institutes, and many collaboration initiatives that we're involved in. So, one example, for instance, is Hypobot, which is a joint industry project geared towards developing a marine standard in charging technology, which is going to be very helpful. It's no use that we develop a charging system and the supplier or the next competition has its own charging technology. That's not going to help the world in the long run. It might be good for our paycheck today, but it's not going to help us in the long run. So that's why we're in those types of initiatives to get that organized.
Great. And another question's just come in Wilson. I will read it out, gents, but I may have to read it. He's asked, how do you see end of life cycle assessments going forward for ships and yachts that are manufactured without recyclable materials of steel and aluminium, especially for composite and cold molded construction? So that he is a yacht design student at the Polytechnic. Have been working on designing a cold molded wooden boat reinforced with bio-epoxy resins and natural fibers to push sustainability materials and carbon negative construction from a materials perspective. But he has found that composite materials are almost impossible to recycle or take immense amount of energy for them to be recycled. So how do you see sustainable solutions for such construction typologies?
That's a very good question.
Repeat any of that, just let me know. Yeah.
No, I can read along. No, it's a very good question. So the reason why we choose composites or composite construction for some of our vessel types is actually a sustainable point of view. It's lighter, it's stronger, you can go faster. Throughout its life cycle, it is with the right skill set easily maintainable and repairable. But the downside is if you take that graph that we showed earlier on how recyclable is it, then it doesn't score very well. For now, we have the conviction that the gains it has in certain ship types, not all, in certain ship types, the gains it has outweighs the downsides of recyclability. But the fact that it makes a vessel more fuel efficient during its life cycle outweighs the other one. That doesn't mean that we're not looking into or talking to organizations that could do something with it. But let's say the material grade or how it's reused, that where steel, if you melt steel, you can reuse it again. You have 98% reuse in the same application. But for composite, you're going to have to shred it into small parts and use it in a completely different product. That's a huge downgrade of the material, let's say, circularity step. But we haven't got an answer yet. That's the honest question.
Okay, interesting. So the work's still going on in development then within the use of composites.
So I would very much like to see the end result of this study.
Wow, there we go. Yes, certainly it's worth then, Kane, getting in contact with Joost, and perhaps he'd be quite interested to hear and see more about what you're doing. And as he just said, yes, he'd be interested to see what the results are from the outcome of the work that you're doing, which sounds very interesting indeed, in hopefully the sunny city of Milan. So great. Well, gentlemen, I want to thank you once again very much for that you've provided and enabling us to see the exciting work that you are doing in helping sustainability and through ship design and development. And I also want to thank you attendees for taking part, and we hope this is insightful and knowledgeable too. If you wanted to learn about how Dassault Systems are supporting and developing the sector, as well as meeting representatives from Damen, then you may also be interested in attending the virtual shipbuilding and lifecycle technology 4.0 event, which is running from Friday the 26th of January to Friday the 9th of February, which I hopefully will believe François-Xavier will once again be presenting. Sure. You'll also be able to join over 6. Great, there we go. Look, you've heard it here, hot off the press. The man himself will be there. So you will also be able to join over 600 industry personnel from over 300 companies to hear François and over 50 presenters in the sharing of knowledge of smart technologies, how we're implementing them, as well as industry challenges and requirements and best practice, as we've discussed today within sustainable ship design. So yes, if any more questions, please feel free to add them now. But gentlemen, I want to thank you once again for your presentation. Thanks once again to the audience for taking part.
Thank you, Jonathan. Thank you, all of you, to attend.
Thank you.
Bye-bye. See you.
Thank you.
Bye-bye.